but you will need to memorize the statements. Okay. So first of all, let's see what this chapter is about. So Euclid was a mathematician. Okay. He was the one who gave this branch of geometry called Euclid's geometry. Okay, what is geometry first of all? What do you guys think geometry means, according to you, in your own words?
The study of shapes.
Yeah, right. The study of shapes. So, geometry, geo means land or earth, right? So, geo means earth, and metry means to measure. We know that. So, geometry is
Okay.
basically that branch of math which measures, you can say, land. Okay, so the reason or one of the ways in which we can say that earliest mathematicians started geometry was the need to measure land, right? They had a need to measure land. So they started
Yeah.
this branch of mathematics. And then later on, as math evolved and advanced, we started measuring other things as well. Then we started, becoming more sophisticated and started putting it on, a Cartesian plane and started giving it coordinates. And then we started. So all of these things, they come under this branch of mathematics called geometry. Okay. So this is a chapter that you will have to read by yourself. Okay. So you must read this chapter because it's just like a story. Okay. So you have to read it by yourself. Um,
Yeah.
okay, so Euclid gave a few axioms and postulates. So, the first thing that he gave, there were definitions. Definitions. He defined what a point is, what a line is. You all know what those things are, right? But the definitions that Euclid gave, actually, they are not mathematically and scientifically accepted today because they are not very specific definitions. But still, if you think about it, that was 500 BC. Okay, that was
Yeah.
500 BC. So thousands and thousands of years ago. So according to that time, his definitions were very well acceptable. So he defined what a point is. Can someone read it? It's going to be when you open the chapter, flip 3 pages, you will find Euclid's definitions, axioms, and postulates. So please read the definition of a point. Someone, anyone? Can you find it? Did you find it in your textbook?
Ma'am, what page number?
Actually, my textbook is different from yours. That's why I can't tell you the page number because
Ma'am,
Okay, ma'am,
5
I
point,
found it.
right?
Yeah.
5.2,
2.
yes.
Yes, ma'am, I found it.
Okay, so someone please read the definitions. What is a
Ma'am, should I
point?
read the, yeah, so,
Just one by one.
okay. So, ma'am, here are the definitions of the elements. The first is, a point is that which has no part.
Okay, just a minute. So, a point is
Yes, ma'am.
that which has no part. Now, this is the definition. You see, math is a whole branch of study in which everything is supposed to be very logical. It is supposed to be very rational, and it's supposed to come out of reasoning. So, if you give a definition of something, then that definition should not be cyclic. Okay, what is the meaning of a cyclic definition? Is that when you say, uh, in this, for example, a point is that which has no part. What is a part? You haven't defined a part. So he doesn't define
Yes.
what a part is. So this isn't mathematically acceptable. Okay. So that is why it's not acceptable by the scientific society. But yes, it is for our common understanding. A point is that which has no part, in the sense that what he said was, so imagine a solid. Okay. You can imagine, let's say, a cube or a cuboid. So imagine a solid. So from solid, now you zoom in, every solid has what? It is made up of surfaces, right? So this
Yeah.
he called surfaces. This is a surface. So a solid is made up of a surface or a plane surface. He called it a plane surface. Now, if you look at the plane surface, a plane surface is basically a plane, right? It's not a solid, obviously. So a plane surface, now he will define it later on what a plane surface means. A plane surface is made up of, like when you go to the corners of the plane surface, you can see it is made up of straight lines, right? They separate this surface from other surfaces. For example, the blue one is one surface, and then the pink one is another surface. So what is the thing that divides these two surfaces? This line
Line.
between them, right? So this he called as a line. He said that two surfaces are separated by curves or by lines. So he said that two surfaces are separated by a curve or a line. Okay, curve or a line. Now, when you look at this line further, you will see that the line, it ends in a point. It ends in a point. So over here also, this line ends in a point. So this thing over here is a point. So if you try to break down a solid, so from solid, you go to surface. And then from surface, you get a line. And from line, you get a point. So basically, a solid is three-dimensional. And in each step, you are reducing one dimension. Okay, students, need I remind you to switch on your videos? Okay, then solid is three-dimensional. Then as you reduce one dimension, a surface becomes two-dimensional, right? It has two dimensions. And then a line has only one dimension, and then a point has zero dimension. That is why he said a point is that which has no part. So you just have to memorize all of these definitions, axioms, postulates. It's just like reading a book, okay? Try to memorize. So what is a
Okay, ma'am.
dimension? Can someone explain? What do you think a dimension means? Yes?
Ma'am, I guess the surface.
A surface is a dimension.
No,
What about
like
line? Huh.
I mean like
Hmm. See, look
the
at this. We are saying that a solid has three dimensions, a surface has two dimensions, a line has one dimension. What does this mean? Like, what is dimension?
Like in solid, we have height and we have the base. In surface, we only have the base, and line also we have only the base.
Okay. So you are thinking along the correct lines, but the language you used is a little bit, let's correct that. So
yeah.
dimension is
So
basically everything that you can
the
measure.
yeah.
Okay. A dimension is something that you can measure. Uh, so in a line, you can only measure its length, right? A line, this is a line, you can only measure its length. It has no breadth, no width, no thickness. There's only one thing you can measure in a line. What is that? It is the length of the line, right? So the line only has a length. And similarly, when you increase a dimension, when you increase this by one dimension, you get a plane. A plane surface, which according to Euclid was a plane surface, we call it a plane. It has two dimensions. Why? It doesn't mean that if you start from here, you can only go up and down and left and right. You can't go diagonal. That means it has three dimensions? No. Dimension means everything that you can measure. You can only measure, like imagine a sheet of paper in front of you, or imagine your screen. You're looking at your screen, okay? In your screen, you can only measure the length of the screen and the breadth of the screen, right? You can't measure the thickness of the screen. You might say, oh, but my laptop or my PC has some thickness. That is the thickness of your computer, not the thickness of the screen. Getting it? So things like a screen, a sheet of paper, the Cartesian plane, these all are planes. We call them planes, and they are two-dimensional because they can you can measure two dimensions of a plane. One is the length and the other is the breadth. You can measure these two things. There is no height. And then the
Height is
third
in
thing,
the three-dimensional.
yes. So when you increase one more dimension, you reach the third dimension, which is the height. So imagine a plane, okay? Imagine a plane surface, and you are giving it some height. You are giving the plane surface some height. Then this thing becomes a three-dimensional figure. Why three dimensions? Because you have length also, breadth also, and now a third thing, which is height also. Okay, so let's come back to his definitions. A point is that which has no part, in the sense that it has no dimension, because here we are saying it has no dimension. A point is it has no length, no breadth, no height, nothing. So it is just a point like this. Okay. So a point is that which has no part. Then he says a line is a breadthless length. What does this mean? Can someone explain this?
That a line does not have any thickness.
Yes, it doesn't have any thickness. It doesn't have any breadth. Okay. It is a length. It is just a length. There is no breadth to it. Okay. Okay. Abdul Jabbar, can you read the third one? Okay. The ends of a line are points. This we already know. All of these things you already know, right?
Yes, ma'am.
Then the fourth point is a straight line is a line which lies evenly with the points on itself. A
Yeah.
straight line.
Should I read the next ones?
Yeah, okay, you can read the fifth one. Yeah, read,
Okay,
please.
ma'am. A surface is that which
One
has
second.
length and breadth
Just a
only.
minute.
Yeah.
Yeah, just a minute, Prishita. Did everyone understand this fourth point? Because I have a feeling some of you might find this confusing. What does the fourth point mean? A straight line is a line which lies evenly with the points on itself.
Like
See,
it
how
connects
is,
both of them in a straight line, both the points together in a straight line.
yes. See, how is a straight line different from a curve? See, there are points on a line, right? So on a curve, it's like the points are not, you can say in one direction. They are going in another direction as well. So
Yeah.
this is how you form a curve, and this is a straight line. So it lies evenly with the points on itself, in the sense that it doesn't go here and there. Okay, it doesn't go here and there. It lies evenly with the points on itself. Okay, then the fifth one. Yes, Prishita.
A surface is that which has length and breadth only.
Yes, it has length and breadth only.
2D.
Yes, these are things that we already know. Just have to memorize this. Then the
Yeah.
sixth point.
So a surface is 2D. Okay. The
Yes,
edges of a surface are lines.
we know this as well. The edges of a surface are lines. Okay. Then the seventh one.
A plane surface is a surface which lies evenly with the straight lines on itself.
Yeah. So this is very similar to what we said about
Yeah.
straight line. So you see, there are different types of surfaces. There's a plane surface and there's a curved surface. Can someone give me an example of a curved surface, a surface which is not plane surface?
Circle.
Circle,
No.
circle is not a surface. Okay, see, this is one a very major confusion that kids at this level have, and that is you think that a circle is a surface, but it is not. Because a circle only includes this line. Only the line that I have drawn, that is the circle. When you talk about this, okay, just a sec. This as well as everything inside it. Now this is called a surface. Okay, this is not. You won't say this is a circle, by the way. This you will say this is a circular surface. Understanding?
Yes, ma'am.
Okay. So, acha, apart from this, anything else? A surface which is not plane. How about a sphere? What is a sphere? A sphere is a like a ball. That is also a surface, right? I mean, it is a solid, but it consists of a surface, and that surface is curved. Okay. How about a cylinder? How many surfaces does a cylinder have? You've all studied this in your
Two.
sixth and seventh grades. It has two surfaces. A cylinder. Yes, a cylinder has how many surfaces?
Ma'am, 2.
Okay, you have this, this, this. Okay. One surface is the curved thing that's going like this. It's going all around the, if you imagine a Pringles box, okay, a box of Pringles, or you can say any such cylindrical box, okay, then,
Yeah.
or a can of soda. The part on which the label of the product goes, that is your curved surface. Okay. Then these are your two circles over here. So how many surfaces are there on a cylinder?
Three.
Three surfaces, right? Okay. So the seventh one was a plane surface is a, I'm not writing the entire thing. Please memorize. Please try to learn this. Okay, remember this. A plane surface is a surface which lies evenly with the straight lines on itself. That means there are straight lines on the surface and it lies exactly on them. Okay. Okay, fine. Then we talk about, okay, great. So then we talk about something that something else that Euclid gave, and that was axioms and postulates. See, axioms and postulates are basically the same thing with just one difference. Axioms and postulates are those statements, they are those statements that do not need to be proven. Okay, that that need no proof. Okay, these are statements that we consider as obvious when we look at things around us by our experience since childhood, by our experience in this world. We can say that we know certain things. For example, we know that if let's say if we know that if two things are equal and you add an equal amount to both of them, then the what you're getting as the overall is also going to be equal to each other, right? And we also know, for example, when we read all of these, you will get what I'm trying to say, that axioms and postulates are basically statements that we do not need to prove, that things that are considered as obvious. Yeah, unless and until someone somewhere finds something in reality which goes against these axioms, then those axioms will be considered as wrong. Otherwise, they don't need to be proved. Okay. Okay, postulates are basically axioms, but they are related to geometry. Okay, things like lines and shapes. So postulates are specific to geometry, and axioms are just in general. But both of them are same in the sense that they are statements that do not need a proof. Okay, Avni, can you read the first axiom?
Yes, ma'am. Things which are not equal to the same thing are equal to one another.
Can you read it again very carefully? Avni.
Yes, ma'am. Things which are equal to the same thing are equal to one another.
Yeah. So what does this mean? Can someone give me an example?
Yes, ma'am. For example, if AB is equals to BC, no, yeah, AB is equals to CD, and if CD is equals to EF, then AB equals to EF.
Yeah. So you are okay. So we are talking in terms of geometry now. Okay. How
Yeah.
about we say
Yes.
something else? Like if I say that, for example, I say that Avni's
Is equals to me.
marks. Let's say if
Yeah,
I say
okay.
Avni's marks are equal to Preshita's marks. Okay. And I say that Zen's marks are also equal to Preshita's marks. Then that means, what does this mean? It tells me that Avni's
Avni and
marks and
Zen's
Zen's
marks are
marks are the
equal.
same, right? So this is the first axiom of Euclid. Fine, very simple, very
Yes,
obvious.
ma'am. Yeah.
Okay. Second postulate, can you read it out, Preshita?
Sure, ma'am. If equals are added to equals, the wholes are equal.
Yes. Can someone give me an example for this? Yeah.
Actually, I have a bit doubt in this.
Okay. What is your doubt?
No, actually, I did not exactly understand
You didn't
what
understand.
this means.
If equals are added to equals, the wholes are equal. Okay. Let's say I have, okay, let's say I have 2 kg of apples. And I have 2 kg of something else. Okay. Let's say I have 2 kg of, so here we are talking about 2 kg. So 2 kg equals 2 kg, right? So I have 2 kg of apples here and 2 kg of, let's say, mangoes here. So they are saying if equals are added to equals, these two things are equal to each other, right? 2 kg equals 2
Yeah.
kg till here, understood? This equals means this thing, that 2 kg equals 2 kg. Now, equals
Okay.
are added. That means you add equal amount of something to both of them. Let's say you add,
okay. Yeah.
yeah, let's say you add 1 kg of pineapple to both of them. You add 1 kg of pineapple here also and over here also. So your overall weight that you get over here will be 3
3
kg
kgs.
and over
Yeah.
here also will be 3 kg.
Yes.
Yes, so this is what it means. If equals are added to equals, so you are adding 1 kg of pineapple to this also and to this also. Okay, fine. Can someone give me another example of this if you have understood it?
Yes, ma'am. For example, if my weight is equals to Avni's weight and Avni's weight is equals to Zen's weight, so my and Zen's weight will be equal. No.
That is,
That
you
I
are
just
saying
gave the example.
first.
Yeah.
That's the first axiom.
So if I have a book which weighs 1 kgs and I have another book which weighs 1 kgs, and if I add two books which equally weigh up to 5 kgs to both the sides, then I get 6 kgs equals 6 kgs.
Right. So we use this in our maths algebra as well, right? We use this in our equations. We say if x plus we use things like this. We say 3x is equal to y plus 7, for example. We say adding 4 on both sides. Yes? Can we do this? Can we do this?
Yes, ma'am. Yeah.
Yeah. Because we know that in order to balance the equation, we need to add the same amount on both the sides. So this is, when we are doing this, which axiom are we using? We are using the second axiom. So, in your test, such kind of questions will be asked more. Ki you are able to perform so and so operation. By which axiom do you relate this operation? Okay. Now let's come to the third one.
Okay, ma'am.
Okay. Abdul Jabbar. Abdul Jabbar. Zen. Okay. Riaz. Riaz. Okay, fine. Avni. Third one, please read the third one.
Okay, ma'am. If equal are subtracted from equals, their reminders are equal.
The remainders are equal. Same thing. The same thing as the second one, right? It's just instead of
Yeah,
addition, we're doing
it's
subtraction.
division.
Subtraction. Okay,
Ma'am,
don't
but
confuse the remainder over here with that remainder which we get in division. The remainder over here
okay.
means, remainder means that which is remaining. So if you
Okay.
have two things and you are subtracting something, you're going to have something left, right? That is what they
Yeah.
mean.
So
For
that's
example,
okay.
if you have two glasses of lemonade, okay, they are both, let's say 100 ml and 100 ml. And you are subtracting 10 ml from this also and 10 ml from this also. So that means whatever is left in this, the remainder is going to be equal to whatever is left in this. Right? Got it? Any doubt?
Ma'am.
No, ma'am.
Okay. Now, Preshita, read the fourth one.
Yes, ma'am. Things which coincide with one another are equal to one another. So, ma'am,
Yes.
can I give an example for this?
Yes.
Okay, so
Yeah.
if like, ma'am, should I give an example in the geometrical thing or in a real life?
You can give any type of example. It's okay.
Okay, ma'am. So if AB is a line and it coincides with CD, then AB is equals to CD.
Yeah, very good. So if AB, I'm telling you that AB is a line or a line segment, and there is another line segment CD which lies exactly on top of AB, then that means AB and CD are the same thing. right? They are equal. Okay, can someone give an example of another another example, maybe a real life situation, just like you said, Krishna?
Actually, I didn't get this one properly. I didn't
Okay, what is
understand.
the meaning of coincide, Avni? Coincide.
Um,
Yes. Okay, this
Ma'am,
is
I
very similar to
don't.
the first one. Okay, but instead of being equal over here, it's talking about coinciding. Coinciding means something that is exactly identical to something else. Okay, this has more to do with physical appearance.
Okay.
Okay, for example, if let's say coincide comes from coincidence. You've heard of coincidence. Coincidence means what? That two things happening unexpectedly happening at the same time, right? Yes, Avni?
Um,
Yeah. So, did you understand this example, Avni?
Ma'am, a bit, but not that much.
Okay, not that much. All right. Preshita, can you give another example? You were saying you have thought of an example from real life.
Yes, ma'am. For example, if I have an apple which is exactly same to another apple, and if I
Hmm.
keep them in a straight line, then both
Hmm.
of them will be equal. Like,
Yeah, you don't have to keep them in a straight line for them to be equal. The thing
yeah,
is, yeah, if they are exactly identical to each other, then they are going to be equal, right? For example,
yes,
they're going to be equal in weight, in size, and if they're exactly identical, right? So, for example, twins, identical twins. Yes.
yeah, yes.
Okay. But that's about human
Um,
beings. And yes, Avni.
like we keep two same glasses with the same amount of water, that also will be.
Yeah. Okay, we just completed the triangles chapter, right? You can think about the triangles. That if there are two triangles and let's say you make them lie right on top of each other in such a way that they exactly fit each other, in the sense that we call it, what do we call it? We call it congruent. Yes. So that means those two triangles are equal to each other. That means they are the same. Getting it?
Yes, ma'am.
Okay. Um, so in other words, everything is equal to itself. This is what it says, that things which coincide with one another. Okay, let me give you another example from geometry. Let's say you have a number line. Okay, then this is your 0, 1, 2, and so on. If I say that this is 1, this is I say Avani's point is 1. I'm giving each of you a point on this number line. So this is Avani's point. Okay, and I'm saying that Preshita's point is the point 2 minus 1. So Preshita's point is also over here. So Avani and Preshita, both of them have the same point, right? Or do they have a
Yes, ma'am.
different point? Their point is
No,
the
the
same.
same.
So that is
Yeah,
why we say that everything is equal to itself. Things that which coincide with one another are equal to one another. Okay.
yeah,
These are just very basic things. It's not like something difficult or anything. Okay. It's just the language that you have to understand. Then the fifth one is also very obvious. Zen, do you want to read it? The fifth one?
Ma'am, can I?
Okay, Avni.
The whole is greater than the part.
What does this mean, Avni?
So like we can take for example a pizza.
Okay,
So like there are we can take like 4 slices in one of them.
okay.
So one of the slice one if we take one of the slice out, it won't be the same as the whole. The size won't be similar.
Yeah, and which one is going to be greater?
The
The
whole.
whole pizza, right? This is very obvious. but that's why we call it an axiom, because it's obvious. So the whole, which is the entire thing, is obviously greater than the part. Okay. So for example, if you have x plus y is equal to z. Okay. If you have x plus y is equal to z, then this
Yeah.
means what is greater than what? Should I say x is greater than z, or should I say z is greater than x?
Z is greater than X.
Yes, because z is the whole. Z consists of two things, x and y, right? So this is x, this is y, and this entire thing
Yeah.
is called z. So obviously z, the entire thing, is greater than a part of it. So that is why we say that the whole is greater than the part. And similarly, z is greater than y also. Clear?
Yeah. Yes.
Okay. Sixth one, Preshita.
Yes, ma'am. Things
Achha,
which are
just a
double
minute,
of the same.
Preshita.
Okay. Yeah.
Just a minute. So there's one more thing that we need to understand from here is that if I say that A is greater than B, if I say that A
Okay.
is greater than B, this means that there should be some number which when you add to B, you get C.
Yeah.
Yes. So the reverse also you can over here you can have it from this. So A is greater than B means that there has to be some number C such that when you add it to B, it should give you C. Okay, yes, continue now,
Yes.
Preshita.
Yes, ma'am. Things which are double of the same things are equal to one another.
Yes. So what does this mean?
Yes, ma'am. For example, if A is the double of like X, and if A is again the double of Y, then
Hmm.
X and Y are equal.
Yeah. So things that are equal of the, sorry, things that are double of the same things, meaning that if X equals Y, then if you double X, if you take the double of X, which is 2X, and you take the double of Y, which is 2Y, then these two are going to be equal to each other. That is what this statement says. Okay.
Okay, ma'am.
Yes, ma'am.
And similarly, the seventh one is just the very opposite of this, that things that are half of the same things are equal to each other. Okay.
Ma'am, can I
So
give an example?
yes,
Okay.
yes,
Yeah.
Ma'am, if we cut an apple in two halves,
yes.
they will be identical to each other.
If
Like
we
they'll
cut
be.
into exact two equal halves, yeah, yeah, you can say that as well. Yes. Another thing you can say from here is that, let's say if you have x equals y and you take half of x, which is half x, and half of y, which is half y, then obviously these two are going to be equal to each other. Okay.
Okay.
Yeah. All right. Let's do some questions on this. Okay. Give me a minute. I'll just get some questions.
Okay, ma'am.
Okay, I will also send you some other questions which you will have to just go through them. Okay. Hmm. Okay, we will do those questions after this, after doing the next part of this chapter, which is postulates, because then in those questions you will need the postulates as well. So these are the 5 axioms. Now let's come to the postulates, and as we have seen, postulates are axioms about geometry. Okay, basically they are uh, obvious statements when it comes to geometry. So Avni, can you read the first one? First
Yes, ma'am.
postulate.
The first postulate is a straight line may be drawn from any point to any other point.
Okay, so now see, these postulates are very important because you will have your exam, in your exam, if there's any question from this chapter, it will most probably be from the postulates itself. So you have to remember the postulate, and you have to remember it according to the number. Like you have to say, this is postulate 1 and the statement of the postulate. Okay. So a straight line may be drawn from one point to any other point. We know that, if you have a point, then you can draw a straight line from it to any other point. Okay. Okay. Then there's an axiom which comes after this. The axiom is, yes, Avni, read it.
Axiom 5.1 give two distance point
Given two distinct points.
given two distinct point there is a unique line that passes through them.
Yes. Now, what is the difference between this postulate and this axiom? Can someone read both of them carefully? Just the two statements, and tell me what is the difference between these two? The first one is saying a straight line may be drawn from any one point to any other point. And the second one is saying that between any 2 points, there is exactly one line. There cannot be more than one line. There's a unique line.
Yeah.
Yes. What is that? What is the difference between these two things?
The first one states that like from one point to the another point is a line, but the second one states that only one line can be drawn by passing it through 2 points.
Yeah. See, the first statement says that between any 2 points, you can draw a line. It says a line. Okay. Between any 2 points, you can draw a line. It doesn't say how many lines. Yeah. You can draw a line, maybe you can draw 2 lines as well. But the second one, the axiom, says that there is a unique line. That line which you can draw between between 2 points, that line is going to be unique, in the sense that there's not going to be any other line that you can draw between these 2 points. Okay. Fine.
Yeah. Yes, ma'am.
Okay, one more thing is that, okay, so let's say if you have a point over here, how many lines can pass through this point? How many lines can pass through this one point?
Infinite.
Yes, an infinite number of lines, right? As you can
Yes.
see in the diagram also, I'm not going to draw, it's going to take a long time. If you can see in the diagram, figure 5.4, an infinite number of lines are passing through the point P. Yes. And similarly, an infinite number of lines is passing through the point Q. Out of these infinite number of lines, there's going to be only one line that is going to pass through both of them. Okay.
Yes, ma'am.
Okay, Preshita, can you read the second postulate?
Yes, ma'am. A terminated line can be produced indefinitely.
So what is a terminated line? Basically, we say line segment. Yes, we say line segment and we say line. So this guy, Euclid, he called this as a terminated line. Means that a line which has stopped. and the line was in the normal sense. What is the difference between both of them? Who will tell me the difference?
Can you repeat it?
Who will tell me the difference between a line segment, here according to Euclid that was a terminated line, a line segment and a line, the difference?
A terminated line, which is a line segment, is it starts from a point and ends at a point, but a line can be extended to both the sides infinitely.
Okay. See, a line segment, both of them, I'll tell you the common things, okay? Similarities, both of them have an infinite number of points. Number of points is infinite. Number of points is infinite for both of them. Okay. But the difference is that a line segment has a starting and an ending point. Just like Preshita said, has a starting and ending point. But a line, it doesn't have any starting or ending point. If you look at any one particular, let's say this is a line, you say, oh, okay, this is the starting point. Well, it's not, because the arrow tells me that you can extend it. So this is what the second postulate is saying, that if you have a line segment or a terminated line, you can produce it, you can extend it indefinitely, meaning how much ever you want. Over here, we don't have space, so we can only do till here. But if you had space, you can just, it will keep on going forever. It will never stop. Okay. A line keeps on going forever. Fine.
Yes, ma'am.
Yes, ma'am.
Okay. Any doubts till here?
No, ma'am.
Okay. Now let's come to the third postulate, postulate 3. Okay. Abdul Jabbar, please read it. Postulate 3. I asked you to read it, so you switched off your camera. Okay. Riaz?
A circle can be drawn with any center and any
Center and
radius.
any radius. Okay. So what do you need to draw a circle? In order to draw a circle, what do you need? You need two things. You need a center. Yes. And you need a radius. So if I ask you to draw a circle, you will first ask me, okay, ma'am, where do you want it to be? Do you want it in the top corner of the page? Do you want it on the bottom corner of the page? Do you want it in the center of the page? So you want to know what is the center of the circle, meaning where do I have to start? So this, let's say if I ask you to draw with the center over here, you will ask, okay, but how big should the circle be? Okay, so that you will need a radius. So a circle can be drawn with any center and any radius. Okay. Is this clear? Very simple.
Yes, ma'am.
Okay. Postulate 4 is very obvious. Who will read it?
All right angles are equal to one another.
Yes. Why are they equal to one another?
Because they all are 90 degree.
Because they're all 90 degree. And we know that things that are equal to something else are all equal to each other, right? So all right angles are equal to each other.
Yeah.
Postulate 5, Preshita.
Yes, ma'am. If a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, meet on that side on which the sum of the angles is less than two right angles.
Okay. So this we will need to understand a little. Let's break it down one by one. And this the fifth postulate, most of the questions that have come in the previous exams in almost all the schools, they come from this postulate, postulate 5. Okay, I will share with you some questions as well. Okay. So it says, if a straight line falling on two straight lines. So there are two straight lines. First of all, let me write like this. If a straight line falling on two straight lines. So these are two straight lines. Though they are not saying parallel lines, okay? So these two straight lines can be like anything. It can be like this and like this. Fine, these are two straight lines. Now there is another straight line, this one. Which falls on both of them. So let's say it is falling like this. Okay. Now, till here we have understood.
Yes, ma'am.
If a straight line falling on two straight lines makes the interior angles on the same side of it, it means this one, the blue one. Interior angles on the same side of the blue line, meaning what are the interior angles? This and this. This is one pair of interior angles, and this and this are another pair of interior angles. Okay. They are saying that if it makes this pair of interior angles taken together less than two right angles. Okay, what is two right angles?
180.
180.
Yeah, 180.
Because one right angle is 90. So two right angles means 180. So two right angles, whenever they write two right angles, just think to yourself 180. Okay. So they are saying that if this line makes the interior angles just formed, if the sum of them, their sum is less than 180. Okay, so first of all, in which two of them do you think the sum is going to be less than 180? In the blue one or in the black one?
I'm in the blue one.
The blue one. Why? Because see, you have studied the lines and angles chapter, right? We know that if there are two parallel lines, then interior angles on the same side of the transversal, this sum is exactly 180. It is exactly 180. Why? Because these two lines are parallel. But if it is something like this, then the place, the side of this transversal on the right side over here, it is becoming wider, right? So obviously this is greater than 180. And on this side, it is less than 180. Okay. So our question is saying, our postulate is saying, on which side are the interior angles less than 180? So as we saw, it is on this side, it is less than 180. Till here, it's clear.
Yeah.
So I'm going to read it again. Let me know if there's any part of it which you don't understand. If a straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles. Interior angles on the same side of it taken together, meaning their sum. Less than two right angles, meaning less than 180. Till here it is clear?
Yes, ma'am.
Angle 1
Yes,
plus
ma'am.
angle 2 is less than 180 degrees. This is what we have seen. Then they are saying, then the two straight lines, if produced indefinitely, meaning you produce it from here also and from here also, then these two straight lines will meet on this side. Which side? On that side on which the sum of the angles is less than two right angles. Meaning, these two lines, see, we know that if there are any two lines, two random lines, then they will intersect somewhere or the other, unless and until they are parallel, right? Yes? You getting me?
Yes, ma'am.
No.
Yeah. See, okay, I think you guys are getting a little confused. So, if you have any two lines, any two random lines, either they will be parallel or they will intersect at some or the other point. So, even if
Yeah.
they are like this, then they will intersect over here. Okay, after you
Yes.
extend them, you produce them. So this is what the postulate is saying, that these two lines will obviously meet, we know that, but on which side will they meet? They will meet on that side where the sum of the interior angles is less than 180.
Yeah.
Getting it?
Yes.
So please memorize this postulate. Okay. So the time is up. Otherwise, we would have just done some questions from this. Acha, let's do one thing. Let's do this one question. Okay. Solve the equation a minus 15 is equal to 25 and state which axiom do you use here. You have to state the number of the axiom as well, along with the statement of the axiom, okay?
8 minus 15.
It is A for apple.
Oh, okay.
Yes. How do we solve this usually?
We will take the 15 to the other side.
See, when we take 15 to the other side, what we are actually doing is we are adding 15
to
to
25.
both the sides. Yes? We are
Yes.
adding 15
Yeah.
to both the sides. So what happens is this becomes 0. 15 minus 15 plus 15 becomes 0. And 25 plus
So we
15
are
becomes 40.
using the
Which postulate?
second
Sorry, which
axiom.
axiom?
Second.
We are using the second axiom. Very good. And you have to state the axiom also. If equals are added to equals, then the wholes are equal. Okay? Is this clear?
I'm clear.
Yes, ma'am.
Okay. Just a give me just one minute. Okay, so there's a question. You have, this is A, B. We will just complete this very quickly. Don't worry. So this is A, this is L, this is M. Okay. They are saying that L and M are midpoints of AB and BC respectively. The first part is, if AB is equal to BC, prove that AL is equal to MC, and you have to tell which axiom you have used here. Yes. Yeah.
Okay, ma'am, just a second. Ma'am, the seventh axiom.
What does the seventh axiom say?
Things which are halves of the same things are equal to one another.
Yeah. So we are saying that AB is equal to BC, which is given to us, right?
Yes, ma'am.
So
Yes, ma'am.
half of AB will be equal to half of BC by the seventh axiom. And you have to state the axiom as well. So half of AB is what? It is AL, and half of BC is MC. Fine. Okay. So there's another part of this question, which is very similar.